Now we're going to do an example on integration by parts. And we're going to start to try to find the antiderivative of the integral of ln of x over x to the fifth dx. Now, you think that maybe we could try doing u substitution. You should be familiar with that strategy. But here that would not work because neither of the terms would have a derivative that would cancel out the other. So we're going to use integration by parts instead, which is implemented through this formula. The integral of u dv equals u times v minus the integral of v du. Now the first step is to choose the parts for the expression for u and dv. So again, we have the integral of ln x over x to the fifth dx. We're going to choose u as ln x and dv as 1 over x to the fifth dx, or x to the negative fifth dx. Now sometimes choosing parts is sort of a guessing game, but sometimes you can have a little strategy to it also. You want u to be easily differentiable, and you want dv to be easy to find the antiderivative of. Now both of these you can see are easy to find the derivative of, but ln x has a more complicated antiderivative, so we're going to choose that to be u instead of dv. And now we have du equals 1 over x dx, and v equals 1 over 4x to the fourth, which is also 1/4 times x to the negative fourth. So now we have these parts, and now we're going to fill them into the formula. Now you can see they're colored correspondingly. So that equals negative ln x over 4x to the fourth minus the integral of negative 1 over 4x to the fourth times 1 over x dx. So now we have this all in black now to be a little bit less confusing. Now we're just going to simplify that. We're taking out the 1/4 and combining the x's inside the integral. And now we're finding the antiderivative. So now we have negative ln x over 4x to the fourth plus 1/4 times negative 1 over 4x to the fourth plus c. And now we're just going to simplify one last step. And that is our final answer, which is negative ln of x over 4x to the fourth minus 1 over 16x to the fourth.